Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are discussing an M1 paper, a walkthrough solution of March 2025. There is only one variant, which is 42. Let's get started right away. The first question, there are some forces drawn. Three coplanar forces of magnitude 40, 30, and x act at a point in the directions shown in the diagram. Given that the forces are in equilibrium, find the value of theta and x. So this is a vertical force, this is a horizontal force, this is inclined at an angle theta, resolve horizontally, resolve vertically. X cos theta to the right, x sine theta down, this equals to this because it's an equilibrium. This equals to this because it's an equilibrium. X sine theta is 30, x cosine theta is 40. We know from our knowledge of trigonometry that tangent of theta is sine theta over cos theta. So this is sine, this is cos. If I take equation 1, divide with equation 2, the x and the x cancels out and I get tangent theta is 3/4. Therefore, theta comes out to be 36.87 degrees. So now over here, based upon the concept of triangle that I draw, if this is theta, this is 3, this is 4, hypotenuse is 5, I get sine, I get cos. I can plug in one of the equation and I get the value of x. So the first question was very simple for 4 marks. Let's get moving ahead. The second question, a nice question, slightly out of the box. A cyclist is traveling along a straight horizontal road at a speed of 4 meters per second. So the initial speed is not 0, it's 4. When she passes a point O, so the story begins from O. She accelerates at a constant rate for a distance of 42 meters, reaching a speed of V. So accelerates uniformly, acceleration is constant till it covers a distance of 42 meters. That's the area of this trapezium and the velocity is V. She then maintains the speed for 50 meters. So instead of time, they have given us the distance and then decelerates at 2 before coming to rest. So there are 3 portions over here. The first portion is red, that is the acceleration, constant rate, the distance is 42, reaching a speed of V. The second one is the green portion, maintaining the speed of V for 50 meters. And the third portion is the purple one, that's decelerating at 2 before coming to rest. The distance traveled while decelerating is 16. Find the value of V, find the total time for which she is in motion from the instant that she passes O. So now, I believe in drawing diagrams. I believe in drawing sketches. I love sketches, and that is how I convey the idea to my students. So this time interval is T1, this is T2, this is T3. Let's get started with the last triangle. That is change in velocity over change in time is acceleration or deceleration. We know that the acceleration is negative, but I'm working with the absolute value. So V over T3 is 2. That's right over here. That is the first step. Let me label it. So this is step 1. That is the concept of slope. Therefore, V is 2 times T3. T3 is the time for the third step of the journey, the third stage actually. So step number 2, that is area of this triangle is the distance covered, and 16 is half into base into height, and the height V is written in terms of T. So I got T first, and then I plug in this value, I get the value of V, which is 8. I'll be needing both of them. Find the total time for which she is in motion, the cyclist. So now this time interval is found, that is 4 seconds. So that is this 4 seconds over here, that is T3. And then how do you find T2? You find T2, that is the area of this rectangle is 50, therefore T2 is this much. So this is T2 over here. And then the first one, that is the area of the trapezium. So area of trapezium is the distance covered. And this distance is 42. So therefore, half into 4 into 8, that is parallel sides. This is the height T1, and T1 is 7 seconds. Total time is exact, no need of rounding off. That is 17.25 seconds. Question number 3, it's about an airplane. I think they got tired of car and van and trailer and maybe a motorcycle or something. So now they're talking about an airplane. The aeroplane is flying horizontally. The aeroplane engines are producing a constant power of 5,500 kilowatt, and the aeroplane experiences a constant horizontal resistance force of 25 kilonewton. So now that's the airplane. This is power converted from kilowatts into watts divided by velocity. That is the force forward. So the force forward, that is power divided by speed. And this is the resistive force, again converted into newtons. And then you say that it's an equilibrium. The forward and the backward force are the same. The resultant force is zero, equilibrium in that sense. So therefore, this thing equals to this. You find the value of V. The aeroplane then ascends 300 meters. Ascend means goes up in 50 seconds while maintaining the same speed. The resistive forces is no longer constant, and the work done against the resistance force during the 300 meter is this much. The mass of the airplane is this much. Find the average power. Now, first of all, let me ask you this question. Why do they write this? The resistance force is no longer constant. That means they write it deliberately so that F is equals to MA is no longer applicable, because since the force is not constant, therefore acceleration is also not constant. So that is why we cannot use resultant force concept, that Newton's laws, F is equals to MA, we cannot use it. So therefore, we have to use the work energy principle. So let me write this thing, the work energy principle that we use for a machine, a trailer which has an engine, a cyclist producing power on its own. So that's how we use it. Work done by engine or work done by a cyclist, something like that. Work done by an external force. So we use this thing. That is change in potential plus change in kinetic plus work done against resistance. This always is on the left-hand side. This is on the right-hand side. Change in potential, if it's going up, we take it to be positive. If it's going down, we take it to be negative. If it's a horizontal floor or surface, we take it to be zero. Change in kinetic, speed increases, it's positive. Speed decreases, it's negative. Speed constant over here, it is zero. So this is the blue one, that's right over here. This is zero. And since it's going up, this is M, this is G, this is H, that is this thing. And the last part, this was already given, multiplied by 1,000 to convert it into joules. So this is what I'm getting. That is the work done by the engine. But work done by the engine, it's power into time, because power is rate of work done. So work divided by time is power. Therefore, work is power into time. So this is power, and this is power, this is time, that's the work done. And then you get the value of P, which is 9,000 kilowatt. So 3 questions are down. Question 4, connected particle. A simple pulley came after a relatively long time. So I think this kind of questions, expect more of it this year. And over here, it says 2 particles have masses such and such. The particles are attached to the ends of a light and extensible string passing over a fixed smooth pulley, and the particles hang vertically below the pulley. They are initially at a height of X meters. So that is X meters above the ground. Above horizontal ground, the system is released. Find the tension and the acceleration. So now this is the heavier particle. This will move down. This will move up. It will move down X. It will move up X, and then something on its own that's coming up on the next page. Particle A, that's the equation. Particle B, that's the equation. Add it all up. That's the system. That is how I do it. Not making the system equation first and then thinking about the particle, that's illogical. Particles make up the system. Make an equation for particle A, make an equation for particle B. If there are 3 particles, make 3 equations. So therefore, over here, you find the acceleration, plug in one of the equation, you find the tension. Now it says during the subsequent motion, B does not reach the pulley. Sometimes it says the string is long enough so that B does not reach the pulley. When A reaches the ground, it comes to rest. Given that the greatest height of B above the ground is 1.2 meter, find the value of X. Now, as a system, when particle A was moving, this is the acceleration of the system. The distance is X. I found velocity square in terms of x. This is just before hitting the ground. Now, particle B, the final velocity from the previous part becomes the initial velocity for B. It moves up on its own as a free particle under gravity till it comes to rest when it reaches a maximum height. So now S comes out to be 0.5x. So this is x particle, this thing moves down, this thing moves up, and this on its own, add it all up, equal to 1.2, and this comes out to be 0.48 meters. Also, you want to do a slightly shortcut. That is, the distance that the free particle moves is 1.2 minus 2x. So 2x, subtract it from the whole 1.2. And of course, you need this thing. There is no shortcut on this. And over here, what you can do is that the distance the free particle moves up, make an equation for that, and you get the value of x. I personally prefer this method. Question number 5, the most trickiest of all, especially the second part. The first part is just easy. There are 3 particles, P, Q, R. These are the corresponding masses. They all rest in a straight line. So first, let me highlight, they all are at rest initially. On a smooth horizontal plane, there is no friction. The distance from P to Q is 3 meters. From Q to R is also 3 meters. After P and Q collide, so first P and Q collide, P continues to move in the same direction. Before that, it says P is projected directly towards Q. So first, the story is about P and Q. This is at rest. It is projected directly towards Q. They collide. P starts moving in the same direction. What happens to Q? We will soon find out. And then it says in the subsequent collision between Q and R. That means Q also is moving forward. It will collide with R, which was at rest. The particle coalesce. They become a single body. That is what the word coalesce means. Find the speed of the combined particle of this after this collision. 2 mark, 1 mark, 3 basic mark. Momentum before collision, momentum after collision. 0.6 into 3 for particle P. 0.4 into 0 for particle Q, 0.6 into 1.5 for particle P, 0.4 into VQ. So VQ comes out to be 2.25. It's positive. That means it's moving in this direction, in the direction towards the right. So let me just highlight this thing so that you are aware. This is the red thing. This is the red thing, and just take care of everything. That's the blue particle. That is the blue particle. And that is what you get, VQ moving in this direction. Now the next one, now it's blue and green. So now this is blue, this is blue over here, and this is green, and this is green over here, and this is the combined particle, which is blue and green. So this is blue and green, and this is green and blue. That is the coalesced particle. Again, that's pretty basic, 2.25 into 0.4, 0.8 into 0, 0.4 plus 0.2, that is coalesce. You want to write the word coalesce, you can go ahead and write it. C-O, not cola, it coalesce, my bad. So C-O-A-L-E-S-C-E, coalesce. And that is a single particle, and that is the combined speed. Now comes the real part, that is for 4 mark. Find the time it takes from when P is initially projected until the instant at which P collides with the combined particle. So that means P still moves in the same direction and it will collide. Now, let me go step by step because that's the only way to success, step by step. P and Q, 3 meters apart, moving at 3 meters per second. There is no acceleration. So basically, S is ut plus half at squared. This thing is gone. S is u into t. T is s over u, which is our old school distance over speed because there was no acceleration. So this is distance 3 divided by speed. So it took 1 second. It took 1 second for the particle to reach Q and collide with it. Now let's start the story of Q. Now the speed of Q is 2.25. There is a distance of 3 meters apart in order to reach R. So therefore, distance of 3 divided by 2.25 in fractions, this comes out to be 4/3 second. Now, is P just stopping there and looking around, or is it moving? No, it's moving. It's moving with a speed of 1.5 meters per second. So in this 4/3 second, what is happening to P? P has also moved. So distance is how much has it moved? This is the speed, 1.5. And this is the time, which is 4/3. This comes out to be 2 meters. So now look at the scenario. First of all, it reaches this. It moves ahead for a time period of how much? That is 4/3 seconds. And in that 4/3 seconds that it has moved forward and collided, P has moved a further 2 meters. So P is now over here. So P is over here and QR is over here. And there is a difference of 1 meter apart. Now the real game starts. So now the thing is, so there is 1 meter gap between P and QR. So now the longer way is that how much further will it be moving till it reaches and collides with that? That is one option. I use the concept of relative velocity. How are they moving relative to one another? This is moving slower. This is moving faster. That is why it's catching up. That means the difference is 0.75 meter per second. Every second, it's moving 0.75 meters closer. So the time to fill this gap is how much? That is 1 meter divided by 3/4. That is 4/3 second. So now focus on the 3 purple things. The first purple thing is this thing. That is 1 second. The second purple thing is 4/3 second. This one is also 4/3. Add it all up, you get 11/3. That is the answer. So it was a very small, wonderful question. Very, very conceptual. Question number 6. Mainstream question of friction and inclined plane. A block of mass 12 kg is placed on a rough plane. Make a habit of underlining so that you don't forget anything. Inclined at an angle of alpha to the horizontal, where alpha is tan inverse of half. A force of X Newton is applied to the block directly up the plane. The coefficient of friction between the block and the plane is mu. Now, this paragraph over here, that is for the whole question, whether it's part A, whether it's part B, it's for the whole question. Now, for each, either you are given the value of mu or you are asked to evaluate mu. Now, in the first part, for 6 marks, they have given us mu. They have given us X. They are asking, find the time it takes for the block to move 2 meters down the plane from rest. There are some basic forces that you need to label right away. Inclined plane, down the plane, mg sine theta or sine alpha. This is mg cos alpha. Normal reaction force perpendicular to the plane. And over here, X is acting up and the value of X is given over here, which is 20. Since the particle is moving down, F max X up the plane because F makes X parallel to the surface and it always opposes motion. So F max is up. F max is mu r. R is this thing. Multiply it with this. That is F max. I'll plug in the value of cosine alpha and sine alpha later. It's moving down. That means this is overcoming these two forces. 12g sine alpha minus F max minus the X force is equals to mass into acceleration. I drew a small diagram over here. Tangent of alpha is half. This is opposite. This is adjacent. Hypotenuse is √5. Cosine alpha is this. Sine alpha is this. Naturally, you can also work in decimals. I plug in all these values. I get the value of A, round it off to 3 significant figures. If it asks at this particular stage, that is 1.46. Now, initial velocity is 0. Acceleration is positive downwards. This is the distance. Use S is equals to ut plus half at squared. This becomes 0 because it started from rest. And then you find the value of t, that is 1.65 seconds. So that was a nice standard kind of a question. The next one, it is given instead that, let me underline this, mu does not equal 2.15. Do not use the previous value. And X is 10, the block is at the point of moving down the plane. Find the value of mu. That is the first part. And then it says the value of X for which the block is on the point of moving up the plane. So basically, this thing over here, that is this part. And this thing over here, let me highlight it a bit. That is this part. So now this is the first thing, which is point of moving down. So this is stage 1. Not stage or step 1, whatever. So now it's at the point of moving down. Therefore, F max is up the plane. So F max is up the plane. Instead of X, the value X equals to 20, X equals to 10. Rest of the working is the same, except it's in limiting equilibrium. Equilibrium with friction in it, it's called limiting equilibrium. So now F max is written like this. And therefore, this force down the plane should equal sum of these two. This force down the plane equals to sum of these two. Make this the subject, plug in the values, evaluate, you find mu. And now you will be moving, you will be using mu in the next stage. So now this is stage 2. That is at the point of moving up, therefore friction is down the plane. So what has changed? X remains the same, mg sine theta, mg cos theta or alpha, r remains the same, only F max changes direction. And this time use the value of mu. So use mu as 0.40683 because over here B part is applicable. So therefore this is the value of mu, and find X in this part. So now what is happening? This thing is down, this thing is down, this thing is up. R is mg cos alpha, F max is mu r. And over here, I have done a bit more of working just to show what to take common. So mu 12, g 2 over root 5, 12, 10, 1 over root 5. So what have I taken common? So I have taken these things common. So therefore, this is 12, this is g, this is root 5, this is 12, this is g, g is this thing. And let me write the value, let me write this thing as 10. Okay, so this is 10 over here. And that is what you do. Let me get a stroke eraser. And let me highlight this. So therefore, 12 and 10 and root 5, that was taken common. What am I left with on the inside? I'm left with this 2 over here and mu over here and this one. This is 1. This is mu. Don't forget the 2. I think I used it when I was calculating it. So I've calculated it from before. So now this is already there. And then this is the value of X, 97.3. Question number 7. A particle moves in a straight line. The velocity of a particle after leaving a fixed point O is given by such and such, where K and P are constants. The acceleration of the particle at t is equals to 1 is 42. And the displacement of the particle from O at t is equals to 1 is 93. So now the red information, let me highlight this. The red information is for acceleration. The blue information is for displacement. So red one is for acceleration. Blue one is for displacement. Got it? So now what do? We differentiate velocity. We get this thing. Plug in t is 1, a is 42. You get equation number 1. Integrate the velocity equation. You get a plus c. How do you evaluate c? From this green information. The velocity of the particle after leaving a fixed point O. That means initially the particle was at O, therefore t is 0, s is 0. That is how you get it. So therefore, the value of c is coming out to be 0. So c is gone. So now rewrite the equation. X is equals to k times this thing. Now this condition, that is this over here, and the displacement of the particle from O at t is equals to 1 is 93. That is the second equation. So you now have the second equation. 93 is k 18 plus half p. You already had the first equation. 42 is equals to k p minus 12. Solve it simultaneously. Therefore, you get two values. K comes out to be 3. P comes out to be 26. That is the answer for the first part. 6 marks, but not difficult. Now this one. Now it says find the distance moved by the particle between the time at which its acceleration is 0 and the time at which its velocity is 0. Acceleration is 0. Write down k p minus 12 t equals to 0. Plug in k, plug in p, evaluate, and t comes out to be 13 over 6. Similarly, v is equals to 0 I did not bother plugging in the value of k because 0 divided by k would be 0. And I plugged in the value of p, that is p, that is p. I simplified this thing. I got two answers. One answer is this thing, which is t equals to 5. The other answer is t is negative 2/3. So time cannot be negative, reject, except this value. So now I have two things. I have the upper limit, which is 5, and I have the lower limit, which is 13/6. Integrate. There is no constant of integration. The integration was done earlier. You can use that result. Plug in the value of upper limit, plug in the value of lower limit, evaluate, and that's how you get this answer. So I think that's a pretty basic kind of a paper, except for that momentum last part. So May, June, that is what you will be giving. And we just have done February, March, and this is 2025, variant 12. And good luck with your exam for May, June 2025. Stay tuned for more content on mathematics with Shahab Yaqub.